All right. Hey, everybody. It's great to be here. My name is Ian Cinnamon. I am the CEO and co-founder of a company called Apex. So today we are going to talk about space. If you look behind me, this photo was taken from, you guessed it, space. It was taken from a satellite that we actually have on orbit that's now been on orbit a bit over a year, made by us here at Apex. So before I go into more detail and tell you all about that, let's take a step back and talk about kind of the space industry as a whole, where we are, where the US is, our allies are, where our near-peer adversaries are, and then we'll dig a little bit into what we're doing here at Apex and walk you through a little bit of a live demo of what it looks like to actually buy one of these satellites. So let's take a little bit of a trip down memory lane. If we rewind several decades back to the 1950s and 60s when space really started, right? What did it look like? It was very difficult to get anything from Earth up to space. Rockets were blowing up all the time. There wasn't really a reliable way to get up there. And the result of that was governments and commercial companies around the world who wanted to launch something into orbit, what they ended up doing was spending billions of dollars on single large satellites. This was the opposite of proliferation. This was the idea of, let's spend all this money, make something perfect, guarantee that it won't fail, and have it last 20 or 30 years on orbit, because guess what? We don't know how we're going to be able to get more things up there. And frankly, for the last, call it like 70 years, this has been how the space industry has operated. And if we think about it, everyday life that we know of today, right? How did you guys get here to Manifest Demo Day? You probably use Google Maps, right? GPS satellites are like this. We have a handful of these big, expensive systems. They work really well, but they're fragile, big, sitting ducks. And what happens is, just like my friend Josh was explaining, who runs Galvanic, if you have a cyber attack, a missile attack, and take down some of these critical assets, everyday life as we know it here on Earth stops. We're no longer able to navigate. Airplanes won't know how to land or where to go, right? The warfighter won't be able to communicate or see over the horizon. Everyday life as we know it stops. So what happened was, about 10 years ago, we started moving to this new architecture that we call hybrid proliferated space. It's a lot of buzzwords. But what it really means is, instead of launching one big bespoke satellite or a few big bespoke satellites, we're going to do some of those, but we're also going to launch dozens or hundreds of smaller satellites. And what happens if you shoot down one of 100 satellites? Well, you still have 99 up there. Or if you cyber attack 5 of them, you still have 95 up there. And you're able to still maintain some level of capability, and the world as we know it does not grind to a halt. Now, this idea is great in theory, but it requires two things to be true to pull it together. The first one is, we need robust and reliable access to get things from here on Earth up into space. And that, thanks to companies like SpaceX and Rocket Lab and a bunch of others that are now pushing forward, I would like to say that that bottleneck has been solved. There's now a reliable way to get from Earth up to space. But then the next question comes down to, are we able to make enough satellites to fill those rockets to meet the need from the US, our allies, and commercial companies? And the answer to that is no. Before I started Apex, I was lucky enough to have a software company. I actually come from a software background, not an aerospace background. And I sold my software company to Palantir. And at Palantir, I had the very unique opportunity to see firsthand how the bottleneck had shifted away from how do we get things up to space, but how do we make enough satellites fast enough? Many of the customers that I was working with that were putting their satellite data into Palantir were running into these problems. Now, we're going to make this a little interactive. If you guys had to guess, I want to see a show of hands. Raise your hand. I'm going to ask you how many satellites you think the US government, so not US commercial companies, but the US government launched last year. So if you think it's more than 1,000 satellites, raise your hand. Okay, a few people. If you think it's more than 500 satellites, raise your hand. More than 100 satellites? More than 50? All right, not many. I don't know if you guys are asleep or if you just think the US government launched none of them. But the point is, the US government launched a bit over 200 last year. Our near-peer adversaries, like the CCP in China, they've announced plans to launch 13,000 satellites in the coming years. orders of magnitude more than we're able to do for US government satellites. And that is a serious problem. So this is the problem that Apex was built to solve. Apex powers proliferated space. So to give you a sense of where we are as a company, in less than 1 year, we went from a blank piece of paper to taking this photo in orbit. You can actually see on the bottom left of the screen, that is actually a selfie, a photo that we took of our team at the time we built the satellite. We were only about 18 people. We're now well over 100 people. But you get a sense of the speed at which we were able to move. Typical in this industry is it takes years to get a satellite actually made. It's now been over a year since we got to orbit, and you could see we keep taking great photos of Earth, but more importantly, we have critical customer payloads on there that continue to function. Customers like Anduril, Booz Allen Hamilton, and other Tier 1 defense primes. And if you come to our facility here in Los Angeles, or not here, but back in Los Angeles, you can actually see multiple satellites being made at once. This is frankly somewhat unheard of in the industry unless you're building one of the same thing over and over again. But to actually be able to build productized satellite platforms to meet this need of the proliferated space market is simply unheard of. So now let me show you a little bit about how we actually do this. So we're going to go ahead to our website, which you can see here. And the thing that, if you're actually in the space industry, will hopefully blow your mind, if you go to Configure Now, you can actually configure your satellite on our website in real time, decide what you want to include, how much power you need, whether you need things like SATAs, et cetera. And then when you're ready to buy it, all you have to do is hit Reserve Now. You could enter your name. And then can somebody volunteer if someone has their credit card on them? I can make the deposit, and you can have your satellite. But the point of this is being able to actually buy a satellite, configure it in real time. This is frankly unheard of. Typical in this industry is it takes 4 years or more to get your satellite made. We could deliver it to you in under 3 months, and we've already done that for customers. So at the end of the day, we at Apex are here to empower you all as our potential customers, as Tier 1 defense primes, as the people who are actually working directly with the end users and end customers. We want to empower you to be more efficient, to be able to move faster, to save money, in order to do what is most important for the US and our allies, which is support the warfighter. So if you're interested in empowering your space program and being able to get more satellites to orbit to power proliferated space, come find me. I probably have a promo or discount code I could offer you on a satellite, today only, and would love to tell you more about what we're doing here at Apex. Thank you.